Hey there, I'm Ed Marcus. I'm a developer evangelist at Hedera. Let's see how to start deploying fast, low cost, and carbon negative smart contracts. If this is your first time trying Hedera, that's okay. I'm going to start from the beginning. So I'm going to show you how to set up your development environment, and you're also going to have access to the code files that we're going to be writing up today. And by the end of this video, you'll know where to get a free Hedera development account, how to write a simple getter setter smart contract in Solidity and deploy it on Hedera, and how to call that smart contract to interact with it. So let's get to it. What you're seeing here in the screen is a page that you can find on hedera.com on smart contracts. And here you'll find some of the exciting things that you can build with smart contracts. So things like auctions, bridges, DeFi, and more. Down here, these are a few code snippets that show how to get started, and we're going to be covering these today, but these are a few commands that you can find in the Hedera SDKs, and I believe these commands are in JavaScript, but Hedera has SDKs for Java, JavaScript, and Go, and also community-authored SDKs in Python and .NET, so it's pretty easy to get started with languages and tools you're already familiar with. And here are some of the good reasons to start deploying smart contracts on Hedera. So the next step, now that you're a little bit more familiar with smart contracts on Hedera, is to create a developer account. You can also go for a mainnet account, but transactions here will cost you real HBAR. Whereas an account that you create here, it gets free test HBAR and it's replenished every day with 10,000 of those test HBAR for you to do all the testing and playing that you may need for your application. So here you can enter some information and get your account. I already have an account, so I'm just gonna log in. And once you're in the portal, this is what the account looks like. So here you can select your the network that you want to see credentials for. So there's a mainnet, a testnet, and a preview net. And in this case, I'm going to go with the testnet for this example that we're going to develop today. And here I'm blurring my credentials so that I'm the only one who can see them. But we're going to use these in a .env file in our project. That's where we're going to keep our environment variables. And now that you have your Hedera testnet account, we're going to set up our development environment. In this case, we're using Visual Studio Code with the JavaScript SDK. The first thing we're going to do is initialize our package or our project. So we'll use npm init. And here we'll work with just default values. So I'm going to click through those. Then we're going to install the Hashgraph SDK. So you see that's installing there, and once that's done, we should see the SDK as a dependency, and that's what you see there. We're also going to install the .env package, and that will enable us to work with .env files, which is where we're going to store our credentials, our Hedera testnet credentials. And then the last one we'll install is a Solidity compiler, so solc package, and that will enable us to compile the Solidity contracts into bytecode, which we'll use to deploy the smart contract. So now our environment is all set, and we can take a step back and think about the objectives that we want to accomplish with our smart contract. In this case, we want to write a getter setter smart contract, and that means that it should have a state variable, and anyone should be able to read and write values from and to that state variable. So you can think of this exercise as having a phone book, that anyone can read and write to. So if we take a look at this lookup contract.sol file, which is a Solidity file, you're going to see we start with these two statements. The first one is the license statement, which is always a good idea to have, and then the pragma statement, which basically instructs the compiler to check whether the version of the compiler matches what we're requiring here in this pragma statement. And if it doesn't match, then the compiler will issue an error. So you'll always see these two statements at the top of a smart contract. So let's start writing our smart contract. We'll call it lookup contract, and we'll put everything in our contract within those curly braces. So the first thing we'll do is we'll create a state variable, and this will be of type mapping. So the state variable is a variable stored on chain on the Hashgraph, and mappings in Solidity are a data type that is used to organize data in the form of key value pairs. So in this case, we'll be mapping a string and a uint. And in this case, uint is just an alias for uint 256, so a 256 or 256-bit unsigned integer. We'll make our state variable public, and we'll call this variable my directory. So this variable is basically the phone book that people will be writing to and reading from when they call the smart contract. So the string will basically be a name, and the uint will be sort of a phone number. So next, let's write the constructor for our function. And this is a function that is called only once when we first deploy our smart contract. And the reason to have a constructor is if you want to initialize state variables. So we'll pass some arguments or inputs to this constructor function. The first one will be a string stored in memory, and we'll call that name. And you'll see me use this underscore variable name notation when we're referring to arguments or inputs that we pass to a function. The second input will be an unsigned integer, and that will be basically the mobile number. We'll make this constructor function public. And what we'll do in our function is that my directory that corresponds to the name key will just assign that mobile number. Right? So when we first deploy our contract, we pass a name and a phone number, and then that basically initializes our state variable. Now we need two more functions, one for setting the mobile numbers and then one for getting the mobile numbers. So let's start with the setter function, and we'll call that set mobile number. We'll pass this function a string that is stored in memory. We'll call that name, and also a uint, and this will be the corresponding mobile number. We'll also make this function public, and this function will do the same as the constructor. So my directory of key name will be equal to the value that we just passed, mobile number. And notice that in Solidity, each line also has to end with a semicolon. We'll fix this typo here. And then the last thing we have to do is write our third function, which is the getter function. So we'll call that one get mobile number. And for this getter function, we'll just pass a string, and that will be the name for which we want to retrieve a phone number. This will be also a public function, and this is a view function that returns a value. And it basically returns the uint that corresponds to that name value that we pass. So we type return in my directory, and we return whatever mobile number corresponds to the name. So now our smart contract in Solidity is complete. But as you know, the Ethereum Virtual Machine, or the EVM, doesn't execute Solidity code. So we have to compile this to get what is called the bytecode, which the EVM can actually execute. So if we save our contract and go back to the command line, or to the terminal, we can compile this contract by typing solc.js. We want a binary file, and we point it to the file that we have been working on. So we may see a few warnings, but that's okay. And after that compilation process is complete, we get this binary file in our directory. So this is the bytecode for our smart contract. Excellent. So now we can go to index.js, which is where we want to call our smart contract from, and also add the Hedera API calls that we want to use. In index.js, we start by clearing the console. Then we require and configure the .env package so that we can access environment variables and access the Hedera testnet account credentials. We also import a few modules from the Hashgraph SDK. These are the ones that we're going to be using today. And then we also require the Node.js file system. After that, we configure the accounts and the Hedera client. In this case, we only have one account, which is the operator ID. That's what we're calling it. And this is an account ID that comes again from our .env package. There it's stored in this variable, and here in index.js we're storing it in operator ID. And then we do the same for the private key of this operator. And note that this is using the private key module. We then configure the Hedera client. We store it in this constant called client. We use a client module, configure it for the testnet, and set these credentials for the operator of our client. And then in this async function is where we're going to be writing all the code and where everything is going to be happening. So if you remember, we're taking 4 steps to deploy our smart contract. The first one was to write the contract and compile it to get the bytecode. Then the second one is to create a file on Hedera and store that compiled bytecode. The third step is to create or instantiate the smart contract on Hedera. And then the fourth and last step for today is going to be calling or executing the contract. So we're going to query it and call it and interact with it. So let's take a step back and now import the compiled bytecode into this index.js file. So we'll store it in a constant called contract bytecode. For that, we'll use the file system, and we're going to use read file sync. And we are going to point that to this file right here. Then we're going to create the file on the Hedera network, and we'll do that using the file create transaction module. So we'll do a file create transaction, and this is using this module, file create transaction. There are a few things that we have to set for this module. One of them is setting the contents, and in this case that's going to be that contract bytecode variable from the previous step. We're also going to set the keys for this file, and this is an array to basically manage that file on the Hedera network, and this is simply going to be the operator key. We also have the option to set the maximum transaction fee that we're willing to pay if you're being cautious of how much HBAR you're spending. So I'll show you how to configure that, and we do that with this set max transaction fee method, and we can configure that to be whatever amount of HBAR we want. In this case, maybe 3/4 of an HBAR is a good measure. And then we can freeze this transaction with the client. We do that to get this transaction ready for signing. And the next step is to sign the transaction. So this file create sign will await, because remember we're doing things asynchronously. So we'll use the transaction that we created in the line above, and we'll use the sign method, and we'll sign that with the operator key. Now it's time to submit the transaction. So we take this previous one basically the signed transaction, and we use the execute method, and we'll execute that with the client. And then we can get a receipt which is that submit transaction when we just execute it and use the get receipt method. So now from that receipt we can actually get some information, for example the bytecode file ID. And so we use the receipt and the file ID. And now we can output that file ID to the console. So we can say bytecode file ID is what is returned to us. Great, so now the bytecode for the smart contract is on the Hedera network, and then we can take the next step, which is to create or instantiate the smart contract. So we'll do that with this contract instantiate tx variable, which is a new contract create transaction. Just like before, we'll set a few attributes here. For example, set the bytecode file ID to the ID that we just created in the previous step. So bytecode file ID. We'll set the gas. In this case, I think 100,000 gas is enough for this transaction. And then we can also set the constructor parameters, which are the values that we want to pass to our constructor function. So set constructor parameters. This uses this contract function parameters module, and then we are going to pass a string, which is going to be the first entry in our directory state variable. So the first string that we're going to pass is going to be Alice, that's the key, and we also want to pass a uint 256. So in this case, we'll just say Alice's number is 111111. So that is our contract create transaction, and now we can submit that transaction. We do that by executing this variable, again with the execute method, and that's done by the Hedera client. Then we can get a receipt, which is the transaction that we just submitted, and use the get receipt method, and the client will be getting that receipt for us. And now we can get the contract ID from that receipt. And we can do something interesting here as well, which is we can display the ID of our contract as an address, meaning in Solidity format. So we can call this new variable contract address, and that is just our contract ID with this to Solidity address method. So now we can basically output these two or log these two variables to the console. So the smart contract ID is this contract ID variable, and the smart contract ID in Solidity format is contract address. So that is step 3, and then step 4 is to basically execute the contract, which includes querying and also calling contract functions. So the first thing we're going to do is we're going to query the contract to check the changes that we made in our state variable with the constructor. So we'll create this variable contract query transaction is a new contract call query. For that module, we have to set the contract ID, which is just the contract ID we've been working with. We set the gas reservation, and this is the maximum amount of gas that you're willing to spend in a transaction. 100,000 gas is good. And then here we set the function that we want to call. So the first input here is the function itself that we want to call, the function name. So we want to call getMobileNumber, or we want to query this function. And now we have to pass the contract function parameters. So here we'll add a string, and we're going to check for the key value of Alice, since that's the value we passed in our constructor. And in this case, this query does require some gas because it's consuming some computing resources from a network node. But one thing to check is that it doesn't require a separate HBAR payment. And we can check that with this setMaxQueryPayment method, where, for example, we can set it to 1 tiny bar, which is the smallest amount possible in the Hedera network. So this should have about 7 zeros. And that is our contract call query transaction there. Now we can submit this query. And as you know by now, this is just the transaction with the execute method. And this will be executed by our client. And now we can get our results with this new variable contract query result, which is this submit transaction, and then we get the uint 256 that we expect in return. We'll take that first entry. Now we can output this to the console. And with a nice message that says, here's the phone number that you asked for. Okay, so this is a good point to check that our smart contract executes as we expect. So let's call our index, or execute our index.js file and see some of the console outputs. Excellent. So we get the bytecode file ID, the smart contract ID, that ID in Solidity format, and then here is the first query that we do of our contract, confirming that our constructor did set the value as we expected. So now we can take the last two sub-steps, one being updating the value of the state variable, right? So now we're going to write to our my directory state variable, and we'll do that with the contract execute tx variable, which in turn calls or uses the contract execute transaction module. As expected, we set the contract ID to be contract ID. We set the gas. 100,000 gas is good. And we also set the function. Just like before, we pass a string with the name of the function we want to call. In this case, it's setMobileNumber. We also pass the contract function parameters. And in this case, we want to add another entry to our mapping. So the first thing we'll pass is a string with Bob's name. And then we'll also add a uint writing Bob's phone number. In this case, it's 222-222. And we'll also set the maximum transaction fee. If you're being mindful about how much HBAR you want to spend, then in this case, we can go really cheap and also keep it at 3/4 of an HBAR. So that'll cover all the costs. Then we can create a new variable to submit our transaction. We'll call this one contract execute submit, which is the contract execute TX with the execute module executed by the client, and we can get the receipt of our contract execution. Which is this transaction with the get receipt method. The client gets the receipt, and we can confirm that this contract execution was successful. So the receipt will contain the status of that transaction. So we can log that to the console with a nice message that says contract function call status. And then one last step that we can take is to query the contract again to check that our state variable changed to receive Bob's phone number. So for that, we could either write a function that queries the contract, or we could just reuse some of this code from the first query. So we'll add ones here at the end of these variables. And in this case, we'll pass Bob to that query. So this is the key, and then it should return the value that corresponds to the Bob key. So now if we go to the terminal again and execute our file, excellent. So that is our smart contract. It's working as we expect. And again, to recap the steps here, we first create the file on the Hedera network with the contract bytecode. Then we create the smart contract. We output the ID of that smart contract. We also output that ID in Solidity format. And then we start querying and executing our contract. So in the first query, we check Alice's phone number, which we passed when we called the constructor, or when we first deployed our contract. And then we did a transaction to call one of the smart contract functions and add Bob's phone number. And here's the query where we get Bob's phone number back. If you want to learn more about smart contracts on Hedera, I encourage you to find this blog post. It will be linked below this video. And it covers everything that you will need to start deploying contracts on Hedera. In fact, you can try this code via a code sandbox, or you can also get the code. If you go to this code check section, you can actually see it in GitHub. So that's where you can get the code and try it for yourself. Also, if you want to keep learning, remember to check out the documentation for the Smart Contract Service. And you can also continue reading about smart contracts in the Hedera Learning Center. And be sure to join the Discord to join the technical conversations happening. With that, I'll see you in the next video.